Hi, everyone, and welcome again to the Musical Innertube. We're talking space today. I'm Don Roney.
I am John Tim Payne, and today we have a very special guest. This is Bruce Betts, Chief Scientist and Light Sail Program Manager for the Planetary Society, and he's here to talk to us about Mars. Bruce, by my count, we have 4 rovers at the same time on the red planet. Am I correct? I was trying to count them. I thought I had a thumb left over.
If you count rovers and don't count whether they worked or not, you've got you have to use your thumb. And there are 2 working rovers and 3 that lasted a long time but aren't working anymore.
Okay, terrific. Because I know we have Perseverance. And I think that is looking for signs of former life or environments where life may well have existed. The wonderfully named Ingenuity, which is being nicknamed Ginny, which is nothing less than an actual helicopter. But I heard, or at least as I gathered information, there's a third one, Insight.
The Insight is a lander, but not a rover. So it's got fixed legs. Its focus is geophysics, basically listening, so to speak, for Mars quakes using very sensitive seismometers and then studying the interior of Mars based upon what they find. The other working rover is Curiosity that landed in 2012, which has the same structure as its newer sibling Perseverance, but different instruments, and was sent to determine past habitability for life as well as learn geology and other good stuff. And it has done that and showed evidence of liquid water that you could have drunk if you were hanging out on Mars 3 billion years ago.
And Bruce, for a person like you who's been working with Mars-related projects for a long time, I just found out that you were part of the short-lived Mars airplane project at NASA about 20 years ago. I'm wondering, what do you personally find most exciting about this present moment? Because it's got plenty of stuff that's just remarkable, and we've been seeing some of the best video we've ever seen from Mars. It's real. You can see it's real, and that helicopter is flying around. I'm just wondering, for you, what do you get the biggest kick out of?
Oh, it's a toss-up between the things that are very publicly exciting, because that's what we're all about at the Planetary Society, is engaging and exciting the public about space exploration. So things like Ingenuity, things like the 2 microphones that are giving us our first ever sounds from Mars, something that the Planetary Society has been working on for 25 years.
Yeah, there it is. That's the sound of the Martian wind that was captured by the rover.
The rovers themselves, the selfies, so to speak, of the rovers on Mars, and then the other side of it for me is the science. So just how much we've learned, how much we know now about Mars in all aspects, everything from its subsurface to have past habitability for life and stability of liquid water in the distant past, all the way to the upper atmosphere and the loss of atmosphere to space over time. So basically all sorts of things is the short version of the answer.
All right. So let's get some of the stuff out of the way here, Bruce. Why do we need a helicopter flying on Mars? And secondly, why were you in a project that was trying to fly a plane on Mars? What's that all about?
All right. Well, we need a helicopter on Mars for traffic reports primarily, especially with all these rovers.
Right.
No.
Got all those rovers running around.
The concept of the helicopter, this is very much a technology demonstration, so it doesn't have expectations to do profound science or even reconnaissance now, but it's to prove that you can do it and that you could use these, and you can use it for this mission, but particularly for the future, use these types of aerial drones to scout ahead of your rovers, to help you pick the best path, the most interesting areas to go to and fill in the resolution between what you can get from orbit and what the rover sees on the surface. And let's not forget that as we talk about flight on Mars, it's a really kind of a ridiculous thing to even consider because the Mars atmosphere is very, very thin. It's about the pressure on the surface is about 1% of the Earth's surface pressure. So it's the equivalent of trying to fly at 100,000 feet-ish, depending on how you define it, which we've never done with helicopters, oh, by the way, and don't often do with airplanes, but that's the environment. And so that's why they have a very light helicopter drone with very, very high RPM on the rotors of the helicopter blades.
Yeah, and it's got like 3 or 4 rotors, right?
It's got 2 that counter-rotate to take out the torques. So that's kind of the deal with the helicopter. The Mars airplane program, little known now, program around the year 2000 when I was at NASA headquarters doing a stint there as a discipline scientist, program scientist. And I got assigned as the program scientist for the Mars airplane. And you may say, the what?
The what?
Yeah, well, you may say that, Don.
Well, I'm glad you asked. The Mars airplane came down from the head of NASA at the time as kind of like, hey, wouldn't it be great to fly an airplane on Mars for the 100th anniversary of the Wright brothers' first flight? And so a lot of very talented people put in a lot of time figuring out what science you could do, what engineering you would have to do, how you would have to do this. But unfortunately, the time scale was way too short, being around 3 years to develop something that's, as I say, just a wild technology development. And the funding was not there to support it. So the concept was that as you're plummeting through the Mars atmosphere and you drop off your heat shield, you deploy your plane with foldable wings and it pulls up at the last moment and doesn't slam into the ground and then flies around to a particular flight path for some period of an hour or so. But again, it's one of the many nifty ideas without complete implementation that have occurred over time at NASA.
Is that viable? Seriously, is a plane viable to do exactly what you were talking about?
It did seem to be viable, yes. Not easy, but landing on Mars is far from easy. Mars is probably the hardest place to land in the solar system because it has just the wrong amount of atmosphere for what you want to do. If you land on the moon with no atmosphere, you can use rockets on the way down the whole way. If you land on Earth, you can use parachutes and heat shields and parachutes and be going nice and slow by the time you reach the surface. But on Mars, there's too much atmosphere to use rockets the whole way down, but not enough atmosphere to comfortably use heat shields and parachutes. And they do, but it's one reason we only land in the lowest places on Mars, or many of the lowest places, because there's not enough atmosphere at the higher altitudes.
So I guess one of the most frightening mysteries about our solar system is the loss of atmosphere on Mars. And I'd love to hear you talk a little bit about that. Obviously, we probably know more about it than we used to know, thanks to some of the many things we're talking about right now. But I'm wondering what the prevailing theory is about why that happened.
So there's been a lot of study of this. Let me give a little background. One of the things about Mars that to keep in mind is that liquid water is not stable on the surface right now. The pressure is too low. Water on Mars acts like dry ice does on Earth, like carbon dioxide. It's either a solid or it's a gas. Well, that's bad news for if you're considering life, at least Earth life, because liquid water is one of the few things needed by all life on Earth. So it's very intriguing that we see lots of geologic evidence of huge outflows of liquid water in the past, the distant past, 3-4 billion years ago on Mars. And there are questions of did it ever pool? Could it have been around long enough for life to develop? And the answers have been yes. But why did it have liquid water sort of stable then and not now? Well, we think it's largely because it had a much thicker atmosphere. and that was lost to space, mostly in the 4 billion years ago. And the process of losing is primarily getting charged particles, solar wind coming out from the sun all the time, slamming into the upper atmosphere, and over very long periods of time, it knocks molecules off and you lose atmosphere over time. The Earth has two big advantages over Mars in terms of losing atmosphere. One is its higher gravity, so it just holds on to things better. And then the other is the Earth's magnetic field, which protects us from the charged particles. Mostly the only evidence we see is in the aurora, the northern lights and southern lights of some of those particles being directed to the atmosphere. But Mars seems to have had a magnetic field in its distant past, but then that process stopped and it no longer has a internally generated magnetic field like the Earth. So those charged particles, instead of being directed around the planet, just slam straight into the atmosphere. And hence you cook for a few billion years and you end up with a really thin atmosphere and no stable liquid water.
I remember seeing pictures of Mars years ago in books where it had polar ice caps. Does it still have polar ice caps?
Good points, good questions. So yes, it has polar ice caps. The base of them and the thick base of them is water ice. But the top of them during the winter is carbon dioxide ice. Mars gets so cold that you actually freeze out carbon dioxide and end up with dry ice over the polar caps. And in one of the polar caps during the warm summer, all the dry ice goes away and you can see the water ice. But in the other one, because of higher altitude, it stays cold and you end up with dry ice year round. Why are we not going there? We have tried to go to near one of the poles with Mars Polar Lander in 1999. That spacecraft failed. And we did go there with the Phoenix mission and this is to, I forgot, but 60, 70 degrees latitude. The actual poles themselves, one, are hard to get to, two, are higher than you want. Remember, we want lots of atmosphere going in, and polar caps add altitude, which is bad for trying to get a lander to the surface. But with Phoenix, we did go to the near polar regions and were studied it until as was expected, the dry ice came in the winter and killed off the spacecraft.
Now, we had mentioned, Perseverance has been very busy, and in our reading material, we noticed that one of its experiments was able to release oxygen from rocks. Did I put that correctly?
Kind of, sort of, but not really.
Okay, perfect.
It's basically
that's John's life is kind of, sort of, but not.
Yeah, I was just going to say that's me, Bruce, all over.
Okay, well, good to know. That's often who I am as well. In this case, the acronym is MOXIE for this experiment, and it takes carbon dioxide. The Mars atmosphere, what there is of it, is 95% carbon dioxide, very unlike Earth with nitrogen and oxygen dominating the atmosphere. And so this experiment takes carbon dioxide from the atmosphere and then converts it splits out the oxygen, which would be useful for future not only human missions for breathing, but oxygen makes the best oxidant to use for rocket fuel.
Oh, interesting. So it's sort of a proof of concept of a technology that we might use if we ever got there.
Yeah, that's exactly what it is. Or even conceptually for robotic, not necessarily requiring human, but where you, for example, wanted to do a robotic sample return and instead of having to carry your fuel with you, you want to make some of it on the surface because it's so every pound, every kilogram that you're trying to send to space makes it harder and harder. Your rockets have severe limits. So conceptually, if you can make your fuel there, you're better off. Obviously, you add more risk to it if you're going to make your fuel there, which is why they flew an experiment like this to see if you could do it.
how close are we seriously to getting manned missions to Mars? That seems to be a big topic, especially in Washington, where every time the government starts to put more interest into the space program, a flight to Mars is what they're talking about.
Well, in my skeptical world, I always like to say a Mars human mission is always 20 years away, and it has been since I grew up in the 60s and 70s. A human Mars mission. So it's a matter of, there are a lot of technological challenges, of course, huge technological challenges keeping humans alive and healthy for that amount of time, bringing them back, which oddly enough most people would prefer, and landing them on the surface with this thin atmosphere. But a lot of it is political will and economics. You have to commit to a long, Apollo-esque type program to really go to the surface. Now, there are other concepts that have been explored, including through some workshops from the Planetary Society, where you start out by putting them in orbit and they operate telerobotically, robots on the surface, which seems odd at first to go that far and not land, but truly landing through that atmosphere and then taking off again is some of the hardest technological challenges you have. So we shall see. It's as much a political question as a technical question, and politics is not my personal forte, though it is that of some people at the Planetary Society.
I wanted to ask another question about something Perseverance is doing. I'm assuming that nobody expects it's going to be sending back pictures of little bitty clamshells on the Martian floor, but I'm wondering what would, in terms of the search for either indications of life or places where life might once have existed, what would constitute an exciting result? The discovery of trilobites aside, but what might, less exciting than that, but still exciting.
Well, they went extinct on Earth, so maybe they went to Mars.
Yeah.
Yeah, no, exactly. I don't actually think that, just to be clear.
Well, thanks for clearing that up.
No, but seriously, folks, there are various things that would be exciting, so to speak. It's going to be extremely hard to ever convince yourself that from one set of observations, unless you see clamshells, and even then you might have to ponder if they're made by something else. It'll be hard to conclude life, but you can get some really interesting indications from seeing the building blocks of life, carbon-based molecules, or even finding advanced proteins, things like that, in the rocks in the record. It is possible, if there was even single-celled life, that they in the past, on Earth's past, have left fossil remnants. So I'm not saying it's likely, but it is possible. You may not see the trilobite or the clamshell, but you may see the equivalent of, if there were life there ever, you might see the equivalent of stromatolites on Earth, which are fossil records of kind of algal mats of life that leave these fossil remnants. So that would be exciting. But also, if you saw any of these other biochemical markers that indicated past life. I mean, this is really, statistically, from what we know, it's much more likely you're looking for past life rather than present life, just to be clear, because of especially on the surface, because it is so hostile now with the thin atmosphere and no liquid water.
Certainly.
That's why they carry a whole suite of instruments, and they'll be looking for building blocks of life, evidence of life, even fossils. I mean, they've got the equivalent of microscopes that will be looking at rocks, but mostly it's looking for biochemical signatures that would be indicative of possible past life as they explore. And they've optimized the search with lots and lots of scientists spending lots of years of work trying to pick landing sites for any of these missions. And for this mission, they've landed near a delta. And so you have outflow of material of sediments that have formed a delta fan like you get at the end of the Nile or Mississippi. on Earth is a really good place in delta sediments to find evidence of past life. And also, they also have other things in this area, including hydrothermal vent evidence, which is a place you find evidence of past life on Earth. So it's a combination of instruments and selection, and now we'll spend hopefully many years doing careful examination of the surface, and we'll see what they find.
It looks like there's also a push to put men and women on the moon for a long period of time, setting up some sort of a base there. And we just had NASA give a huge contract to SpaceX to develop a huge rocket, not a Apollo 3-person rocket, but a huge rocket that can take hundreds of people to the moon. What's the thinking behind that?
Landing humans back on the moon is currently an active program. And again, we've seen those cycles before and they've broken down, but the previous administration and this administration have both committed to doing this. So it's much more likely than it has been in the past. The concept and like what SpaceX was awarded was really the lander, the equivalent of the lunar module from the Apollo days, what goes down to the surface, and then would be launched presumably on their rockets. So, and there also is the concept of building a so-called lunar gateway, which is something that stays near the moon in orbit. That would be kind of like a small version of the International Space Station, but really far away near the moon instead of 400 miles up and orbiting the Earth. So again, I'm not very good at predicting the future. I'm much better at thinking about science, but especially when the future involves politics. But it's certainly an active program that's being put forward now. And so it is very, very possible that in the next few years we will have humans returning to the moon.
That is very exciting to hear. It's really exciting. I remember, and Don and I were of the generation where we, got up at 5 a.m. because we lived in very early in the morning because we lived in California. And, we had our blankets and our pillows, we sat up and turned on the black and white television and watched the whole thing. It was, it would be very exciting to see people do it again, because I guess we probably are a lot better at a lot of the things that we did back then.
Yeah, certainly the technology is wildly more advanced now than it was then. It's making it all the more miraculous what they achieved at that time.
So I wanted, we love the Planetary Society, as you know, and one of the friends of the Innertube is Mr. Mat Kaplan, who's been on here several times. And one of the things I wanted to ask you to talk about is the Light Sail project. It's one of the most beautiful things orbiting the Earth, I think. This gorgeous, a silvery sail. And I'd love you to talk about what it does and, what the project is up to now.
Sure. So Light Sail 2 is in orbit right now. It's a Planetary Society spacecraft that's demonstrated successfully solar sailing in a really small spacecraft. So solar sailing is using just the pressure of light, which is pushing on you and me, unless you're doing this in a dark room right now. But it's just a very, very, very tiny push, and it gets completely overwhelmed on Earth by other things like the atmosphere, the wind blowing around. But if you take a really shiny sail, in our case, aluminized mylar, basically a thin version of what mylar balloons are made out of, and you put it with a small mass spacecraft, then that push from the sun actually becomes significant, and you can actually to change your orbit or use it for propulsion. And the Japanese demonstrated the first solar sail. We actually tried to and then had a rocket failure in 2005. The Japanese had the first solar sail mission, Icaros, in 2010. But what we've done since then is taken and incorporated solar sails into the rapidly growing miniaturized satellites. So basically, our spacecraft is about the size of a loaf of bread, and it opened up, and out from it came a sail that's 32 square meters. It's about 5.5 meters on a side, about 17 feet on a side, and we used that to demonstrate that we could actually not only open that up in space, which is non-trivial, but actually control the orbit and use solar sailing to change the orbit, to modify it. And we've done that. We're still in space. We're taking lots of pretty pictures as well, as you mentioned, with the silvery sail in front of. And we continue, basically, this was a demonstration mission of this ability. And so we're actually in an orbit that, because we're also have this big sail and a low mass, we're very susceptible to what little atmosphere is 700 kilometers above the surface of the Earth. You think of it as a vacuum of space, but there's still molecules there. They're gradually bringing us down, and eventually will burn up in the atmosphere. But in the meantime, we're continue to work on learning about solar sailing and controlling the spacecraft, and trying to get people excited about this technology as well as space exploration.
What's the idea behind that technology? The idea that we could send a spaceship and it would be propelled by more or less solar panels that look like the sails?
You get your power from solar panels, but it's actually the sails that are getting pushed. Getting the push of light. So it's a push of light rather than a conversion of light energy into electricity.
All right. And so this would be, you would be able to get them big enough to move a spaceship with, say, people on board?
That's pretty distant future. It's really more the concept that you can use it to take your robotic spacecraft and enable missions that are hard, if not impossible, to fly with conventional rocket propulsion. Because you, like a sailboat, you don't have to carry fuel. And anytime you can lower the mass of your spacecraft, you can get more rides to space or get a better ride to space, depending on the size of your rocket. So by having this ability to not ever run out of fuel, you can encounter multiple objects. They go between inner planets, go to multiple asteroids. You can do missions to between the Earth and the Sun to give warning of solar storms that are headed towards Earth and can damage telecommunications things on Earth. We've got those now, but there's only one stable point to put your spacecraft and not have any thrust on it. And that's about 1 million miles, 1.5 kilometers towards the sun is the stable gravitational point. But with the solar sail, you can constantly have this propulsion to balance you in what would otherwise be an unstable orbit and provide more warning for solar storms. So they're just enabling different things. And we were particularly excited about demonstrating this in these small CubeSats, they're called, because they're based on a 4-inch by 4-inch by 4-inch or 10 centimeter square cube that are kind of standardized and have allowed a lot of organizations and agencies and universities to fly spacecraft in Earth orbit. Now we think this will enable groups to use these very small spacecraft to bum rides off of other bigger spacecraft and fly distant places in the solar system. So NASA's actually doing this themselves with a 2-loaf-of-bread spacecraft instead of one, in a mission called the Near-Earth Asteroid, my terminology, not theirs, in a Near-Earth Asteroid Scout mission, they call it, that will be launching sometime in the next year or so, where they will take this beyond Earth orbit and go explore an asteroid, but by piggybacking on a launch of other satellites.
For years, that's been part of NASA's problem. You're judged by the size of your rocket.
Yes, exactly.
Well, you still are. I'm not going to go down that road.
You know, it's this stuff. It is so exciting, and I personally just can't get enough of it. Space exploration. You know, we have regular visits to asteroids now. You know, and we're getting. I think they've even we've gotten really close. If we haven't landed on a comet yet, I think somebody has taken samples of them. And it's just some things that we thought about or heard about when we were little kids, and now a lot of it is getting done. I just think it's a great time to watch this unfold.
Yeah, no, it's a golden age of space exploration now, I think, and particularly referring to the robotic program, we're going a lot of places, doing a lot of interesting things, doing more and more sample return. We're looking forward to sample return in the future for Mars even. We've done it for asteroids. We've got samples coming back right now from the OSIRIS-REx mission from an asteroid. There's just a lot of great stuff going on right now.
And one of the things that has got me smiling is the fact that everybody's involved. Different countries are launching different satellites to Mars and the moon and asteroids and that sort of thing. But does this sort of bode well for everybody getting together and combining on space missions?
Yeah, I mean, a lot of countries already are cooperating, hence the International Space Station, but also in these robotic missions. So very often when the European Space Agency flies a mission, it's got American scientists on the team and vice versa. And same with the Russians are working with Europeans going to Mars. We just had the United Arab Emirates spacecraft go into orbit at Mars, working with Americans and others to make that happen. There's an Indian Space Agency mission at Mars as well, and they've had ones at the moon. And again, very often they carry instruments from other countries, other organizations. So there's more and more international collaboration going on, and groups flying different exciting missions, different places.
Well, Bruce Betts, thank you so much for talking to us and taking us through the solar system with the landers and the rovers and the helicopters and light sails. It's just wonderful. It expands the mind just to be talking about these things. Thanks for coming on the Musical Innertube.
Yeah, thanks, Bruce.
It was fun. Thank you very much.
And thank you for listening to the Musical Innertube. If you'd like to find out more about the Planetary Society, visit their website at planetary.org. Get in touch with us by sending an email to musicalinnertube, all one word, @gmail.com. And you can follow us on Twitter. John is @JTimPayne, Don is @DonRooney9. Our webpage is Musical Innertube, that's musical spelled with 2 A's, .libsyn, spelled LIBSYN.com. The Innertube is available on Amazon Music, Facebook, YouTube, Apple Podcasts, Stitcher, Spotify, SoundCloud, iHeartRadio podcasts. Like us and give us a good review on any of those platforms. And head on over to musicalinnertubeplayers.libsyn.com to check out some fine radio comedy. And as always, thanks to virtual band Car Radio Dog for our theme music.